So lesson 3.6 is our last lesson for this unit, and it's so focused on applying these functions in the real world and kind of how you may see this rate of change happening and being used. So it says, our first question here, Lily has a $20 gift card for music downloads. Each song costs $2 to download. The amount of money left on the card can be represented by the function. So this is our equation that we use, where D is the number of songs she has downloaded. So that will be important. Her $2 download and her 20 total. So make a table and graph the function. So remember, D is the number of songs downloaded. So number of songs, or you can think downloads. We are going to set this up just like we did when we did the tables in lesson 3.4, I believe. So we're just going to, you can start at 1. In this case, I think we're going to start at 0 because we want to think about what is her starting point. So 1 and count up. So 1, 2, 3, 4, 5. All right. For, we pronounce this M of D. Plug D into the equation and solve. So this equation here is this one that they gave us, okay? So I want to do, for each one, I don't have a lot of space here, but I'll try to write it in. So it's 20 minus 2D. And that's kind of showing us, okay, $20 is her starting point. And then you're subtracting the $2 per download or per song. So here I would plug in a 0. So you can type that whole thing, that whole expression in your calculator, just 20 minus 2 parentheses 0, or you can do the multiplication part, this first. So if I did that, it'd be 0. So 20 minus 0 is 20. All right, I'm going to do that for each value. So 20 minus 2 times 1 would be 18. So go ahead and take a pause on the video and try to complete the rest of this column. Okay, hopefully you paused and are now checking your answers. So if you notice, it went down by 2 each time. And just to kind of give you some context here, this would be how much money, M for money in this case. All right, the last column just wants you to write your answer as an ordered pair. And it's going to be, instead of X, they put D. So that is the number we picked over here on the left. So that would be 0. And then for Y, they put M of D because that's another way to write Y in function form. So that is just what you got when you plugged in. So we think, remember, D for downloads is our input. The money left here is our output. Okay. So B, identify the initial value for the situation. Well, this is like how much money did she start with on her gift card, and that was $20. All right, identify the common difference or the rate of change. So how much is it going up or down each time? Well, we're spending money, so it's going down, and $2, so that's like -2. I'm going to go ahead and go back and do the graph before we go on to D. So I'm going to, remember you want a title and then a label for each axis. Okay, so I'm just going to say gift card money for my title. All right, we said D was the X, and here's my X-axis. I don't need to make like the graph in the middle like that because all of these are positive, so I can just use the positive quadrant. So X is talking about number of downloads. All right, and then the Y, or the M of D part, is talking about money left on the gift card. So I'll say money on card, something along those lines. Those don't have to be like a set thing. You can you have a little leeway with those. All right, now each of these is a point. So now I just want to graph each of them. Let's see what our graph goes up to, though. We have to pick a scale. So it only goes up to 14. So you may just do, we can just go by twos, and that would be fine. So I'm going to label this 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. We really wouldn't need further than that. And on the downloads, I'm just going to go by ones. So make sure when you get to the test that you have each of these parts labeled, like your, your titles and the axis on the graph, etc. Okay, so my first point is 0 and then up to 20. So take a minute here, just pause and plot each of those points. Okay, hopefully you're checking your answer, and this is what you should have gotten. So it is forming a linear function here, makes a straight line. It would pass the vertical line test as well. All right, D, so identify the domain and range of the function and explain the relationship they have on the situation. So a little bit, there's a lot in that question. So domain and range, remember X is my domain, or my input, range is my Y. So if I'm explaining those, I would say, okay, well, domain range, I'm going to explain the relationship. I want to identify those. So if I'm identifying those, I'm just going to take all of the numbers that are the domain. Remember, when you're doing points, you list those in brackets and from least to greatest. So 0, 1, 2, 3, 4, 5. And then the range will be all of the Y values. And then I'm going to start at the bottom of the table to work up. Okay, and then it also says explain the relationship they have on the situation. So really just as she gets downloads, what's happening. So you could say something in the lines of the more downloads, the less money on the card, or for every download, the gift card amount goes down $2. Anything like that. So let you kind of put that in your own words. Okay, our second part here today of applying these functions is looking at interest. So if you're talking about interest, talking about money in the bank, how much is that earning, how much is being added to your account. So we have a specific formula that's used for this that I put over here. And you do get this formula on the test. So just, you have to know basically just what to plug in, okay? So the situation we're looking at, your parents made a savings account for you when you were born and added $200. So principal is the initial value, or initial money. So in this case, it's 200, okay? The amount is what you're finding typically. So I'm just gonna write what you're looking for. So they rarely give you that. It's usually what you're trying to find. The rate is the percent of interest. Oops. So in this case, it was 1.5%. And actually, I want to change that. It's the percent as a decimal. Okay, so to make 1.5% a decimal, so I have 1.5%. Okay, to make it a decimal, you divide by 100. So divide by 100. Okay, which is going to move your decimal 2 places to the left. So then I would have 0.015. All right, and then time. Sometimes we'll leave that as just a t and plug it in later. So in this case, they have not told us the time yet. So I'm just gonna have to plug that in here in a little bit. So I'm just gonna say t. In this case, we are talking about years, so it could be different based on different formulas. But all right, A, write an exponential growth equation for this situation. Simplify your equation, completely showing all of your work. Okay, so like I said, already have the formula. So you want to use a specific formula that they give you. We do not have the amount yet, so I'm going to leave A. I do have the principal. The principal was 200. And then I have a 1 plus the rate. Remember, that rate is as a decimal, so 0.015. And then to the power of t. All right, now simplifying means, all right, look at this. What can I combine? What terms do I have? That sort of thing. So on this one, I have this portion of the expression in parentheses. I can just add that together. Okay, so I'm going to do A equals 200. 1 plus 0.15 is 1.015. And then to the t power. Okay, I'm going to show you what you cannot do. You cannot multiply 200 times 1.015 yet, because if we are doing order of operations next, exponents comes before multiplying. If you do PEMDAS, if you remember that. So this t applies to the 1.015. So I cannot go any further on that. I just need to stop right here, and that would be simplest form. Okay, now we're going to do our table like previously. So create a table to represent how much money you will have after 5 years. Then graph the table and label each axis. So we want to work up to 5 here, but we still want to start at 0. Okay, so 0, 1, 2, 3, 4, 5. All right, here we're going to plug this number in to here. I would definitely recommend your calculator on this. I'm going to grab mine. So I'm going to do 200 parentheses 1.015 parentheses, and then remember, so here let me write this here. So 200 parentheses 1.015. This little key, it's called caret, looks like an arrow pointing up. My calculator, it's on the top right side. It can be different for different ones. And then t is going to be whichever value we picked. For this one, it will be 0. So to the 0 power is what that means. So in that case, I would just get 200 because that is my starting point, so that makes sense. Definitely need a calculator for this. So if this is on your test, so I would recommend using the one that you're going to use for your test. So I'm going to stop and fill in the answers for you. So I want you to pause the video, try to get these on your own, and then replay the video to check your answers, okay? Okay, you should be checking your answers now. I did have to round on a lot of these, so I wrote all of number 2 down, or the 2 years down, to show you how to round that. Since it's money, we want to round to the nearest hundredths, which is the 4. So I would look behind that. 5 makes that 4 go up. Everything else will stay the same. So it would be 206.05. 3, 4, and 5 years I already rounded, so you don't have to worry about those, but hopefully you were able to round those on your own. Okay, I'm going to erase these off. So I have room, so it was 206.05, I think. All right, so graph the table, label each axis. So you want your time was what we plugged in. So anytime you're plugging in, that is your input or your x. And again, I only have positives on this. So I'm just going to use this as my positive quadrant on the graph. So time in years goes on my bottom label, and then value in money goes on the y-axis. And then you can just put something at the top like savings account or savings interest, savings total, something along those lines, okay? All right, And now each of these that we found over here is a point on the graph to show that relationship between the years and the value. All right, so you want to think about, I do not want to just like start this kind of in a random spot. I'm actually going to do, I'm going to do each line down here on the bottom be like a half. You can do one, it gives me a little more space to make it more visually kind of easy to read, I think. So I'm going to space that out to 5. I could go to 6, but I don't really need 6 in this case. Now the value, or the y-axis, I definitely don't want to go by ones because it starts at 200. So I would begin by just putting a break in your graph. So we go like this, and that was a little bit off. Let me try that again. Kind of like that. Sort of looks like a heartbeat monitor, I feel like. So I'm going to break, and I'm going to start it at 200. All right, and then think, okay, well, the next number it goes up to is 203, and then 206, 209, 212, etc. It's going about by threes, so it may be easiest to do that. It is not exact numbers, but you know, I'm gonna have to gauge it a little bit in there. But so I'm actually gonna count by threes here, but I'm gonna use 2 spaces to do it again to give me a little more space. So technically I'm going by like, and this is 200 here, technically I'm going by like 1.5. So I'm gonna go up 2 spaces and make that 203, and then 206, and then 209, 212, 215. There are multiple ways you could do this that could be correct. I thought this was the easiest spatially to kind of show us where we have enough space and we can kind of see what's going on here. So our first point is 0, which would be, I didn't actually label that, but that would be here. And then up to 200, which is here. So I got that one. All right, 1, 203, another nice even one. Next one gets a little off, so 206.05 though. Okay, so that's gonna be like probably not even that much above the line, but I can't get much smaller there. 4 would be 4 years, so I would then have a total of 212.27. Okay, so I want you to think each of these 2 spaces is going up by 3, so halfway is 1.5. So this point is like 213.5, okay, which we don't really need, but if I'm at 206.05, oops, I skipped one, sorry, 209.14, sorry, that's still going to be like barely above. It's really hard to even graph that accurately, so as long as you put it like a smidge above, then you're fine. All right, 4 years, I've got 212.27, again, barely above, maybe just a little bit more. Got to mark those. And then 5 years, I'm at 215.46. So that's about here. Okay. Got my graph. So it says predict the amount of money, for C here, you will have on your 18th birthday. Round your answer to the nearest dollar. So whole number here instead of hundreds. So I'm going to use the equation I had before. A equals 200. I want to use my simplified one. And then I'm going to do to the exponent of 18, since that is 18 years. Let me figure that real quick. Remember that it's super important that you have a calculator on this, so that you can use for the test as well. All right, so it looks like if there's no change in the principal, like we don't add money to the account, etc., then she'll have earned, it looks like 261.468, but they wanted the nearest dollar. So nearest dollar is the 1 here. So I look behind the 1, it's a 4, so that would stay, and those squiggly equals mean approximately, to 261. The 4 would make it stay the same. So that means if they didn't put any more money in the account, they will have earned an additional $61 over 18 years just based on the interest alone. Okay? All right, hope that all of that makes sense. I know today was kind of a lot, but if you have any questions, please message me. All this will be on your test, so I want to make sure you have a good understanding and that you're able to complete your homework accurately. Okay? Have a good day.